Ian, welcome to the Leanpub launch video for Harness Engineering, building reliable workflows around non-deterministic agents. I was wondering if you could take a moment to talk to all of us a little bit about yourself, about who you are and what you do, and what your book is about and who it's for.
Yeah, definitely. My name is Ian, and I'm a staff engineer at Parento, and we are an insurance company that it provides companies a way to uh, offer parental leave benefits to their employees as a benefit. I've been doing the leading of the AI adoption that we've been having there, and most of what has come out in the book has actually been from my experience of the past 6 months with experiments and different things that have come out of that. Some of that has been directly applicable to my job. Some of that was additional stuff that was a corollary, experiments, but not something that I directly applied at the job. And yeah, that's pretty much what I do. And recently I've been very interested in harness engineering and in really understanding what it is and how it fits into the agentic workflow. I initially got interested in that after reading an article from Birgitta Bokler. I am not sure if I'm saying her right name right. But that really got me interested, and that's what kind of set me on this path. And then luckily, I had enough freedom and flexibility and trust at my employer to be able to really implement some of these things in order to really test them out, to have some concrete examples. And then that ended up becoming the book. And the book is essentially about how I was able to wrap those things up. One thing that's very, very difficult with agentic coding is getting good output. And that's because the agent is non-deterministic by design, and it's never going to not be. That is the way it is designed. It's a feature, not a bug. So I believe that our new role as engineers is really to constrain what is allowed there, to accept that there is non-determinism, but to also wrap enough reliability layers around it to be able to prove that the code that we're shipping is reliable and it is going to work, even though it was produced by an agent. And most of those have already been implemented already. I don't really introduce any new concepts or ideas in the book. Instead, I really just apply older concepts that have already been proven out by many people. Um, Things like extreme programming, continuous delivery, abstractions, like all of the canon that we have in in the engineering industry, it applies and it works. And it applies even more so with agents because agents amplify all of these things happening. So tests were important before, they're even more important now with agents. And so a lot of what I do in the book is to kind of apply those things and show how I was able to wrap that system around the agent, and then get good quality results out of it and see improvement over time as I was able to shrink basically the solution space of what was available to me.
Can you talk a little bit about Bridle and Sellier, if I'm
Yeah.
pronouncing that correctly, and Keystone? I
Yeah.
love the. It's actually a very interesting kind of origin story for your book that it was in like kind of not that many programming books aren't based in real world experience, but in this case, it's kind of builds upon itself in a very
Yeah.
kind of useful and interesting way.
Yeah, so whenever I initially got into harness engineering, I was really trying to figure it out. And after I built up my own Claude config files and things like that, and started giving my agents context, the next thing I wanted to do was be able to figure out how to do that in a generic way. We were working with a Laravel project with React. So lots of things I put in the code base that were specific to Laravel, specific to PHP, that I otherwise would not have put in there if I was using something like Ruby or Python. And so a lot of the inspiration that came from that was realizing that it could be generalized, that it could be scoped out to a larger tool, that it didn't have to be that the project itself needs to have something that is explicit and detailed for that project because each project is unique. But there are general ideas that overlay all of that, and that's what can be pulled out into a general abstract layer. So maybe in Ruby, you use mixins, and in PHP, you use interfaces. But the whole idea, the general idea, is to prefer composition over inheritance. And so if we apply that,
Right.
then we're able to get up to the next level. I started off with Bridle. That was a Claude code plugin. That's what I'm currently using. And so I built what I could there. And I feel like I took that to a pretty good limit and ran into the problem of distribution. It was no problem to get the plugin up, but as I was thinking about supporting additional coding agents, I realized I did not want to maintain five, six, seven different plugins for different coding agents. Um, and so that's what was the inspiration for Sellier. Sellier
Mm.
is actually French for saddle maker. That's why I chose that word.
Okay.
And so that was a more general tool. That was a Python tool, which is on PyPI at the moment. And it installs a very generic base. And then from that, you can then enter your coding agent and then have it fill in all the gaps, have it kind of fill in this template of these high level ideas that, in terms of your stack, in turn, they turn into these particular recommendations, like whatever that happens to be for your specific use case for JavaScript or Ruby or Python. Now, after I was able to do that, I did finally run into some limitations there as well, because I did not like that it was its own separate tool. I did not like that the agent couldn't talk to it, or that it was uh, incomplete in terms of setup. It seeded something, but it didn't really finish setting it up, and I didn't like that. So I wanted to be able to connect it with the agent, and that's what ended up turning into Keystone. And the thing that I really liked about Sellier is that it would drop some stuff in, and then it would get out of your way. You could
Right.
install it and then uninstall it, and it works. All it needs is your coding agent. It doesn't have a runtime. So that was really great. So I took that idea and carried it into Keystone. And then when using that, I also added some other additional pieces into Keystone that I had learned along the way, lessons from Bridle, lessons from Sellier, and then also lessons that I learned as I was figuring out distribution, and how these things actually apply to the agent level. So it was a lot of experimentation and a lot of different versions until I got to where I am currently. But at this moment, Keystone is basically something that scaffolds and maintains a harness for you, and you can talk to it through the agent. And it also has a CLI, so that way you can do it yourself in the terminal if you prefer, but you also can have your agent talk to it, and it will be able to do things like bootstrap your harness, so that way all of your files are applied in terms of your preferred patterns, testing things, um, conventions, and then also anything additional that you wanted to have in there. There's an MCP server that is able to get those rules, apply them. We're able to add new skills, guides, and sensors, and that just allows for more of an ease of use for the user. Especially with the flywheels. Keystone has two flywheels. It has a learning flywheel and a pruning flywheel. That's to be able to maintain the harness so that way it doesn't accrue too much debt. If you have too much, if you have too many rules, that could become a real problem where the agent really actually starts to get worse.
Right.
And so you have to have the pruning side as well. And that is also available through the MCP. So while you're in the agent, you can just call the MCP server, and then you can go through those cycles yourself. You can go through those learning and pruning flywheels yourself. And that is one of the big practices that I found that was important, was being able to maintain uh, some kind of flywheel so that way you're able to control your harness debt.
Thanks very much for that really great explanation of the origins of the book and the sort of like I love the kind of sequential experience that you kind of went through learning along the way and building new kind of things in a kind of evolutionary way, which is a really powerful way to develop technology and books. The last question I have for you is your book is currently, I'm looking at it here, it's marked at 99% complete. Uh, I've seen other authors do that. Why is your book marked 99% complete?
Yeah, so the reason is because I have a few additional resources I'd like to add to the appendix. And I also have a few items that I've marked in the book specifically as targets for errata, because things are constantly changing. And I know that things are going to shift a little bit. And whenever I get that information, I expect I'll be able to add that in. So that's definitely one big piece of that. Another thing is that I just realized that a lot of this actually decouples into a separate model. So now I'm actually kind of rethinking about the structure of the book. So the content will likely stay the same, but will, maybe rearrange in terms of the way that the model is portrayed. So that way it's a little bit easier to understand.
Cool. That's a really great explanation. The book is really good too. It's Harness Engineering, Building Reliable Workflows Around Non-Deterministic Agents by Ian Johnson. Ian, thank you so much for taking the time to talk to all of us today a little bit about yourself and about your book. And thank you very much for using Leanpub as a platform for publishing it. It's just amazing to see books like yours come from our perspective, come out of the blue and great authors like you as well. So thanks very much.
Thank you. Thank you. That's great. Thank you.